Determine the minimum number of states required. This is required in DFA to accept the strings over 0, 1 whose length is at most n. Here option A is given as n states, option B n plus 1 states, option C n plus 2 states, and option D n square states. Here the DFA should accept the strings whose length is at most n. That means the maximum possible length of the strings is n. So let us solve this problem by taking one example. Let us say n is 3. Let us take n as 3. That means we need to construct the DFA which accepts the strings of length at most 3. So the DFA will be this one, as at most 3 means it can accept strings of length even 0. So initial state should be final state. It can accept strings of length 1. So this can be final state also. This can be final state also. Even this can be final state. As this is a DFA, we need to have transitions for each and every input symbol on all the states. So here we have to give transitions for 0, 1 for this state. So if we give transitions on 0, 1 to any of these remaining states, then it will accept the strings of length greater than 3. So we need one dead state. So we can give transitions from transitions on 0, 1. So this from here on 0, 1 it will go to dead state. So this is a DFA which accepts strings of length at most 3. So we can say here the number of states is 5. So we can say the number of states in a minimum DFA which accepts strings of length at most n is n plus 2. So here correct option is option C. In this question, a code segment is given and we have to find the number of multiplications saved after eliminating the common sub-expressions in the given code. Here the given code is P is equal to x star y plus q, R is equal to x star y star c, T is equal to x star y plus u, and V is equal to x star y. So if we see here, eliminating common sub-expressions is one of the code optimization techniques in which we will try to eliminate the common sub-expressions if there are any. So if we observe the given code, there is x star y in each and every statement. So let us write this x star y as t1 x star y. Now p would become t1 plus q, and r would become t1 star s, and t would become t1 plus u, and v would become t1. This is a code after eliminating common sub-expression from the given code. In the earlier code, the number of multiplications are 1, 2, 3, 4 and 5. After eliminating, the number of multiplications are 1, 2. There are only 2 common sub-expressions. So we can say the number of multiplications saved after eliminating common sub-expressions is 3. So here correct option is option B.
Which one of the following is not true about the threads? So we need to find out a statement which is not true. Option A, regarding the threads. Threads in the same process share the same address space. This is true because, for example, in a process, if it is executing on multiple threads of control, all the threads within that process will have to share the same address space only. They cannot share the address space of the other process these are the threads of a particular process. So the statement is correct. We need to find out a statement which is not true. Option B, context switching between threads in the same process is typically same as the context switching between process. This is not correct because for example, process P and process Q is there. P is having T1, T2, T3 are the threads, and Q is having some TQ, TQ2, something like this, let us suppose. So in this case, switching from process P to Q requires the saving of the status of P and reloading the status of Q, because the PCB contains a lot of entries, but whereas when you are switching from one thread to another thread in the same process, we require to save only limited number of entries, because the thread control block containing only limited number of entries, because it is a lightweight process, both the switchings are not same. One process to another process switching is different from one thread to another thread within the same process. It takes very less time because both of them are in the same address space. So but it is saying that it is typically same, that's why the statement is not true. Option C, a thread is a flow of control through a program with a single execution point. Yes, this is also true statement. None of this. Option B is the right option here, because it is a statement which is not true.
Let processes are scheduled on a system using round robin scheduling. Assume that there is only one process of R time units. Round robin time quantum is Q time units and process switch time is S units. If S is less than Q is less than R, then process switch overhead is. Here it is given that there is only one process of time units R. That means the burst time of that process is R time units, and here scheduling algorithm used is round robin with time quantum Q units, and context switch time is given as S time units, and time quantum lies in between switch time and burst time of the process. Here we have to find the switching overhead of the process. Switching overhead can be found by finding number of switches, total number of switches in scheduling that particular process. Here burst time is given as R and time quantum is Q. So number of switches would be R by Q minus 1. Why minus 1? Because for first time there will not be any switch overhead. That's why R by Q minus 1. Total R by Q minus 1 switches will be there, and switch time is given as S time units. So R by Q minus 1 into S is the switch overhead. So here correct option is option C.
Which one of the following statements is false?